All right. So the most important part is that when the program runs through internally, it will maintain program stack, and then it will store what are the local variables for the function, and then what kind of arguments are passing to the function, and then what are the arguments we are passing to the other function. Yeah. So these three set of the arguments, local variable, and then argument passed to the other function. These are very important. And then starting from week 2 and on, we will mainly focus on altering these kind of values, return address and save ABP. Yeah, that's why this kind of layout is important. And then let me share another thing. Some of students keep mentioning about Ghidra, or they're like the automatic decompilation or something. And then some students are using that and some other does not use that. And then I intentionally did not disclose anything about Ghidra for week 1. And then for this week, it's okay to all you guys use like the Ghidra, but the reason is if you just go Ghidra and then use that, and then you will never see the details of the assembly line. So that's why. So for the challenge solving and then for earning the score, it's all okay to use Ghidra and then use the decompilation result. But at least please follow how I do that. And then after that, you will be much more clear about how all the thing works. And then for those who they have a struggle with the installing Ghidra because it requires a Java and then all the other stuff. Yeah. So instead of using Ghidra, I use a different tool called Cutter. Yeah. So this tool internally has Ghidra inside of it for the decompilation, and then it has a neat GUI, definitely not Java at all. Yeah. So it's available for the Linux, Windows, and Mac OS. So I recommend if you are not that good at Ghidra and the others, yeah, please use Cutter. And if you download and execute it, then you can select a file from the file browsing window. And then from our challenge server, we can download the binary program from the link. Yeah. And then after you download that, click on the open the file with the default setup. Then what you will get is some of the list of the functions or symbols that here, and then some of the disassembly result. And then if you click on the main function, you can see the main function, something like this. Oh, this is a buffer overflow level 4, then I will open the regular level 4. Yeah. Select level 4, open it. And then this is the main function, but at the bottom here, you can see that there is a tab called decompiler. If you click it, then you will see this something looks like a beautiful source code for that. And then if you click on the password, then it will do the decompilation of the source code for you. Yeah. But the important thing here is that, so I'm not sure you can see the characters here or not, but I'm not sure how I can increase the text. It's not possible. Yeah. But these texts are something like this. But here, the important thing here is that all the variables are named as a variable 204H, 23CH, something like this. So it's very important to understand the meaning of the numbers here. And then to give a little hint, these are all hexadecimal number. And then that's why it is attached with H, yeah, indicating hexadecimal number. And then 244, 240, 23C. These are all indicating the relative distance from the EBP, the base pointer, to the variable. So what that means is that so each of the variable indicates, so there could be a lot of local variables, something like this, and then each of variable, for example, var 240H that means EBP minus 0x240 hexadecimal, then that's the place where the local variable is located. So by taking a look at these numbers, so it's very important to reconstruct these kind of the stack diagram, and then later you need to exactly calculate where your return address and then save the EVPs are in week from like among across week 2 to week 5. Yeah, so that's the important thing. So I'm okay to use like this kind of result, but the manual reverse engineering is not that difficult. So I will demonstrate how you can do that. So let's start with the level 4. So first thing we need to do is like we need to check what the main function do, and then just copy and paste. And then this is the main function. So we know that main function is look like something like this. And then we just cut. These 3 parts are reserving a new stack. So it push EBP means that it will save EBP at here, and then move ESP to EBP means that. So now the EBP is on the stack. Yeah, and then subtract 8 from ESP means that it will reserve a new stack space by subtracting ESP at here. So in this case, it does not have many of the local variables. That's why it just subtract 8. Yeah. And then in this case, it should subtract 1, 2, 3, 4, 5, 6, 5, 6, 7. So 7 multiplied by 4. And the reason why we need to multiply by 4 is that we are playing with the 32-bit machine. So all the addresses are, these kind of blocks are 4 bytes. Yeah. And then please don't get confused. All the numbers on the right side are hexadecimal number. So 4, 8, C is 12, and then 10 is 16. So increasing by 4 byte, decreasing by 4 byte. That's the common thing in 32-bit machine. Yeah. And then, so we are using stack to pass argument whenever we call a function. Yeah. So now we have a printf call here, but how we pass the argument is, so at the location of the ESP, we will put the first argument, ESP plus 4, second argument, ESP plus 8 is the third argument, and so on. So to get the argument of the printf, so it puts EAX to the ESP plus 0. So there's nothing at here, so it's right at the ESP. And then that means this EAX value comes to the put on the stack as an argument. And then you're curious about what this value is. And then for this kind of value, if you have a dollar flag right in front of any kind of number, then that's just a number. But if you do not have dollar flag, then that's the address. And then another thing you need to check is that the instruction, there are 2 instructions that you can play with the address. So one is LEA, that's load effective address. And you can think it as like taking the address. So you can use this as an address, and then whenever you see LEA, then regard that as a pointer. Yeah. And then another instruction to play with the memory is like a move instruction. And then move instruction is putting the value. So LEA is for pointer, move is for value. So we know that this is an address, and then LEA, yes, this value, this one is passed as an address. And then from the printf, we know that the first argument should be const character pointer as a type. Then we can expect that this is a sum of the string literal. And to examine that value, you can examine string literals by address on GDB. So examine string x/s with the address, then you can get this string value. Then we can just copy and paste, and that's it. That's the line for the running printf. And then after that, so we'll call password, then it will call get, and then they call calculate. And then these are function epilogue. So now we can summarize main function by deleting all the dirty assembly lines, and it will be something like this. And then after that, let's get into the functions one by one. Password, get, and calculate. So the password is quite a long function. So the function size is starting from 0 to 418. So it's around more than 400 byte of code in the function. But this code is not that optimized, so it has a lot of like a redundant part of the assembly. So we can ignore many of the points. So I'll just copy entire disassembly of the password. Yeah. And then, so you can always skip the first few lines of the assembly by taking a look at the maintaining ESP, EBP, and then subtract ESP. That's all about the maintaining the stack configuration. So these are function prologue. And then next thing that you can focus is like there is a memset call. And then whenever there's a function call, we need to identify where how this function passes argument to. So let's check to check the arguments, we need to focus on the how ESP is accessed on this function, in this function. So the first argument is ECX. Second argument is 0. Third argument is 200. Then feel free to ask any question if you're confused about like what I'm demonstrating. Yeah. So from these 3 lines, we can easily identify these 3, and then we need to identify where this ECX comes from. And then few above lines, then we can identify that there's a LEA EBP minus 204. So we use EBP minus 204 as a variable, and then we regard that variable as a pointer. So if this one is moved, then we are taking the value from there. Then this is the instruction is a load effective address. So we are taking the address of this one and then put that on ECX. So we can safely assume that this is some of the buffer located at the EBP minus 204. So we can write down something like this. And then let's try to analyze the next function call. So it calls scanf, and we know how we use scanf, something like this, right? So that we can expect that there could be several arguments, and then to identify arguments, we need to take a look at how ESP is being used. So EAX is going to put on the first argument of this scanf function. Then where does it come from? EAX comes from EBP minus 210, and then EBP minus 210 comes from EAX here, and then that EAX comes from here. Yeah. So even if there are a lot of lines of the code, so if there's a no register name for that register, you can safely assume that that value will never be changed. So to infer what is the value of the EAX, I just follow this EAX that is coming from here. Yeah, that's it. And then to check what's in there. So that's actually getting 20 characters. So we can change the scanf as this one. And then what is this second argument? Second argument comes from EBP minus 214. And then EBP minus 214 is coming from ECX. And that ECX is actually this one, the buffer. Yeah. So first line, zero out the buffer, and then second line gets input from the user to the buffer. Yeah. And then the next function call is string length. And then we know that it has only one argument. And then we need to focus on that how ESP has been used. But this is a little weird, but the program puts ESP to EDX. So now we need to read this as a ESP. It was EDX, but we overwrite EDX value with the ESP. So this line actually stores our first argument to the string length. And then that EDX comes from LEA of the EBP minus 204, the buffer that we are using. So it gets the length of the buffer. And then one caveat, one hidden thing that I didn't tell you is that whenever we make a function call, the return value will always be stored into the EAX register. So the same thing happens, same thing applies to the x86-64. So they will use RAX register to store the return value. So we can safely assume that the EAX will be the length of the buffer that we give the input, and then that will be stored into EBP minus 208. So we know that variable 208 is storing the string length. And then the next is a comparison and jump. So whenever you have a comparison instruction, it's important to distinguish if that is an if or if that is a for or while loop. And then to do that, let's focus on the compare and jump equal. Then it will jump to 184. So 184 is here, and then the instruction right before that jump target, I don't know why. No, it shows. So instruction right before the jump target is exit. So it's not about like getting back to the somewhere into the program. So we can safely assume this is not a loop at all. This isn't just an if condition. And then we will write the if condition, and then it will compare variable 208. Yeah. So that was the length of our input to 0x10, which is number 16. So I will use decimal number here. And then the condition is E equal. But we are jumping out if the value is equal. So we can write it as something like this. And then it will print out some of the message and exit. Then you can definitely sure that this is not the right answer because our goal is to execute the get a shell function, right? And then, but let's check what kind of message it prints out. Yes, it says long string length. So what it does is like our input length must be length of the 16. Yeah, that's the thing. And then the next function call is strtoul. So string to unsigned long. Yeah, that's the meaning of the strtoul. So it will convert any kind of string into decimal number in unsigned long format. Yeah. And then if you're curious about the function signature of the STRTOUL, then you can just copy and paste this one. Then now we know that it will receive 3 arguments. And then beautifully, they use ESP plus 4 and 8. This is our first, second, third argument. So we can replace it as EDX 0 and 0xa, which is 10. 10, 0xa, 0, and EDX. And that EDX comes from EBP minus 0 to 04. That's the buffer. And then every time the function call finishes, it will store the result into the EAX register. Yeah, that's hidden here. Yeah. Then the next function call is SNPrintf. And then search for the SNPrintf, and you can get the signature of the function. Then we can expect at least 3 arguments should be there. And we are seeing 1, 2, 3, 4 arguments there. Yeah. And then just put it in order, ESI, DirectX14, EDX, EAX. And then let's figure out each of values. So ESI. No. So this ESI comes from the LEA of the 0x204. That's the buffer. So you can write it as a buffer 204. And then this is just a literal value. And then in decimal value, it's 20. And then this EDX value. So the EDX value comes from here. And then this is LEA, so we can expect that that's a string literal. Copy. And on GDB, then we can get it that as a %D. And then finally, EAX. So these 2 lines are actually doing meaningless thing. It puts the EAX to the EBP minus 20C and then get it back. So these 2 lines will never change the value of the EAX, but where does the EAX has been assigned? This one, right? So even if like EAX was disappearing somewhere here, then the important thing is like that whenever you make a function call, it will overwrite the EAX. So we can rename this as a result of STRTOUL, and then that will be placed as the number. Yeah.
Overwrite EAX or only once it returns?
So if there's no return value, it does nothing about the EAX. Yeah, but think about it. Suppose you do not. So there's a function foo, and then function foo internally calls function bar. So suppose function foo does not have a return value, but the function bar has a return value always 3. And foo bar return, then the grandparent caller will get 3. Yeah. So like if there's no return value, there's no specification. So I believe compiler will do nothing about that. So it will show you the return value of the some other function. Yeah, that's possible, but we cannot guarantee. Yeah, that's the thing. So after doing that, it calls a string compare. So we can easily know that it gets our input, checks the length, and then transform that into the sum of the integer value, and then print it out again as a sum of the text, and then it will do string compare. And this also has a register name hiding trick. I don't know why the compiler did that. So it will put ESP first on the EDX. So we can regard this as like putting the first argument, and this is putting the second argument. And then the first argument is definitely buffer. and then second argument is this one. Yeah. So this as value is stored onto the stack, and then let's check what this value stores. So the result should be matched with this kind of string. So function is something like this, and then string compare. The result of the string compare will be stored onto the EAX again, and then the next thing is like it will compare against the EAX, and then if that is not equal, then it will call some of the exit printf, something like that. But internally here, if that is correct, then what it will do is it will do printf. And then the first argument is coming from EAX, and that's here. Yeah. And then that's where we can get the correct password. Yeah. Then let's collect what we have decompiled. So we can write the password function like this. Then I will delete the assembly lines. So it was something like print incorrect and something like this. Delete. Then, so we know that the result was something like it should be equal, then correct password or something, or otherwise print out some wrong value and x and -1. So this is what we have reverse engineered, and then let's check that with the automatic result. So this is the result from the decompiler. Yeah, and then this is the thing that we don't buy manually by hand. Yeah. So it's not that totally identical, but you can see that the flow is very similar. Yeah. So I know that it just took 1 second versus around 20 minutes. Yeah, I know that. But what I want to tell you is that one thing is like when you write the exploitation code. So if you get these kind of the layout value 1 byte wrong, it will never work. So you need to be very precise with the surgical precision to control the bits and values to achieve the successful attack. And then sometimes this kind of result does not give the correct view of that. So whenever I do the play CTF and or like even if like the hacking iPhone or the real thing, so even the paid version of the IDA Pro, yeah, they will generate the incorrect decompilation result because they do use some of the approximation optimization kind of thing to beautifullize their code. So sometimes their calculation could be incorrect. So the reason why I'm demonstrating this thing is, so there could be a case that the decompilation fails. then even if the compilation failed, don't stop it there. So reverse engineering is not that difficult. It takes time. Yeah. But after 7-8 hours, you can construct some sort of the beautiful C code. Then that could be reducing the time rather than like the playing with the incorrect decompilation result. Yeah. So I know some of the hackers that they don't use either decompilation or those kind of tools at all because they don't like that kind of like the not getting the exact or like the correct values about that. Yeah, but I'm the person also who also like the decompilation result. So that's why like I'm not opposed to like the just do the like the hard reverse engineering. You know, I'm not that person. Yeah, but make sure that whenever the tools fails, then you need to know how to work around. And then I'm demonstrating the hard way about doing that. But yeah, hope you feel the hardware is not that difficult. Yeah. So it's all about getting the argument correctly or something like that. Yeah. So any questions about this kind of method for reverse engineering? One of the questions that I received from the previous class was like are real hackers doing the same thing? Yeah. And I believe so. I've seen many of hackers just using paper and pencil, try to reverse engineer a single function for several hours. Yeah. And then because I didn't enable any kind of the optimization, so reverse engineering is easy. But I believe if the code is not intentionally obfuscated, that means if you use a general compiler and then just use -O2 or all fast, that kind of the regular optimization option, then the code generated by the compiler is not that hard to read. Yeah. But there's a way to like defeat the reverse engineering. So we cannot completely defeat the reverse engineering, but we can make the human engineers tired. Now, like maybe like we can let them spend 2 years to reverse engineer one thing. But in the meantime, we will have a 10 version update. Then we can win, right? As a defender. Yeah, there is some of the method like that, but with the obfuscated code, then the reverse engineering could be super difficult. Yeah. But that there are many ways that we can use. So for example, so I just demonstrated the static method. That means I didn't execute the program at all. Yeah. But if you use the dynamic method, that means you can run the program and you can examine the values at runtime. Yeah. So if you do so, then like your reverse engineering will be much more interactive and easier. Yeah. And then the next thing is about like after understanding this. So I've seen that some of the students have having difficulty on figuring out what are the solutions for the each challenge. And then for level 4, if you follow the code here, maybe I should save it as, see, then it will be highlighting the syntax. Then it gets up to 20 characters, but the length must be 16. But their decimal conversion to the text must be this value. Then how can you make these 8-character string as a need to be 16 bytes, but still have this value? So the computers are very dumb, and then they are working as the coded in the code. And then, so I'm not telling about ChatGPT and then artificial intelligence. They are smart, but these computers are very dumb. And then, so what we need to do is like, we need to type this number, but in 16 characters. And then there are many ways of doing that. So one easy way is doing something like this, attaching a lot of zeros in here. Yeah. Then another way is we can attach 8 white spaces. Oh, long string lengths. What? Doesn't work? I think it's a scanf. It will cut on this white space, right? Yeah, that's why. Then we can do something like this. This also works, right? Because the string QUL will stop it here. So, and then.
I also proceeded a bunch of zeros.
Oh yeah, that's good. So one thing that I would like to tell you is that, so what we will do is not about we will use the function in an expected way. So if we do something in an expected way, then there will be no hacking. So what kind of developer will design their program to be hacked, right? Yeah. So please keep that in mind. So there is no one right way in applying the successful hacking. Yeah. And then maybe there's only one way to build a good and then robust program. And then I believe in stealing some flag or something, there are arbitrarily many ways. So for overcoming this kind of hurdle, so please be creative and then do whatever arbitrary method, then you will get past through the thing. And then one of the interesting thing was so level 9 that internally generates prime numbers, and then it will ask you to submit a number that is not divisible by those prime numbers. So the answer might be you can calculate another prime number for it, but some other students just type -1. Yeah, so you will realize that with the -1, with the division operation, to take a look at how it works, yeah, then you will see that this is somewhat working. And then how that works is like the -1 is actually the 2 to the 32 -1 in the unsigned integer format. And then what it does is that value is keep divided by with all the prime numbers, something like that. Yeah. Any questions for that? Yeah. Then let's move on to level 8. So for level 8, so this is the main function of the level 8, and that it will do get the time and then see the random with the time, and then it will run password function. And what it does is, so it will get a random number, and then random number plus 15. And so random number divided, get the remainder of the 20, and then add 15. So that it will generate the number between in the range of the 15 to what is that, 34 or something, right? Yeah. And then what it will do is it will keep generating number with the sequence with the 3, 4, add previous 2 to generate the new one. So it works like there's something similar to the Fibonacci numbers, but starting with the 3 and 4. But your task is based on this kind of the random number. Then you need to get that position of the what is that? The sequence. So the one way of the solving this is like you need to analyze the thing and then write the program and then, so for example, so it says 34, my lucky number, then 3, 4, 7, 11. So that kind of the sequence generation stops at the 30th position. Then we need to type that number to pass the result. Yeah. And then 21, 40 at a time. So it'll be keep changing. So you might need to write a program. But there's one way that you can fix the random value and then get the answer easily. And can you guess how we can do that? Yes? So we can actually fix the random. Then can you get to the point how we can do that? Yes. So we cannot change the time, but what we can do is, so take a look at how it is seeded. So before running the password function, we get the time and seed that and use the time as a seed, right? And then so this is the time function. And then do you know what is the granularity of this value? Second, right? And then what that means is that so we will have the same 34, 34, right? So what we can do is run level 8 with GDB, run without GDB at the same time. But you don't have to be exact same time. Within the 1 second granularity, we can do that. So for example, what I will do is, okay, then, let's do it again. No, miss. I'm not used to this kind of a key combination, that's why. That works. So if you manage this to be working, then you will have a debugging instance, will have the exactly same random number with the other instance. Then what you can do is like just set the breakpoint at here. Yeah. Then you can get the value from GDB. Yeah. And then you can get you can put that value into there. Yeah. Right. So any question about that approach? So make sure that this trick, I have a challenge in week 7 that requires you to exploit this kind of the random trick. So please memorize that, and then I will do the recap again when we get to the week 7, because the week 7s are like after we learn all about the skills, and then like the challenges it requires like a mixture of the skills to solve that. Yeah. So any other questions for the week 1 challenges? No? Yeah. And then like the, I know that several students have finished it until week 2. And then like the, although we will do the lecture for the week 2 next week, I don't want to, those who like finish it, all the challenges are boring for the class. So I will create some of the super difficult extra credit challenges for you guys. So yeah, so don't get disappointed that I will release the week 3, not in this weekend, because I don't want to push the other students too much. But there will be some fun extra credit challenges, and then their score will be high. So for the students who don't want to solve like the regular challenges, just target the extra credit challenges. That's also okay. Yeah, so I'll do that. Yeah, right. So any other questions before starting the in-lab exercise for like taking Q&A from you guys? Yes.
Doesn't really have to do with the protein category, but do you ever learn like something like Z3 for like a red zone?
So at the end. So although this class is titled as a cyber attack and defense, I think that this class teaches a 90% attack and then 10% defense. Yeah. And then, so we do have some part of the learning about some of the tools or techniques other than like the manual reverse engineering, exploitation, those kind of things. So around the week 4 to 5, we will learn about some of the defense mechanisms. And at the end, around the week 9 and 10, I will share like some of the tools that automatically finding vulnerabilities and how the automatically generating exploitation works. So definitely, that will definitely include Z3, and then not just for that. So it will include the symbolic execution and then all the other stuff. Yeah. And then Rudy mentioned about the Z3, and then that's actually the constraint solver. And I don't know how many of you know about that. So theoretically, we can convert these kind of program into logical expressions. So something like and, or, that kind of thing. So theoretically, the programs are equivalent to that kind of the logical expressions. So if you cannot imagine what kind of logical expressions are, then please recall that your algorithm or complexity class. And then we have seen that there is a satisfiability problem about the MP when we get to the MP complete. So there are like the X1, X2, X3 that are all ORed and those kind of things. So actually all the programs are equivalent with that kind of thing. So if we can solve that kind of logical expression, then that's equivalent to we can find the vulnerability or something. But interestingly, we learned that that's MP complete. Then that means if we use that, finding vulnerability is also in MP complete. Yeah. So sometimes humans are super fast, but sometimes for the easier thing, yeah, even for the TSP, yeah, the difficult MP complete solutions, for if the size is small, then computers are finding easy the solutions quickly, right? So for some cases, like the computers are very good at the exploiting the program automatically, yeah, and then that's possible, and then we will briefly learn about those. And also, I'm always accepting some of the topics that you guys want to learn. So if that is directly related to the cyber attack and defense, please share that on Discord or something. Then I will try to include cover that around the week 7, 8, 9. Yeah. And then before that, we will just focus on the learning a lot of attack techniques. All right, then if there is no more question, then let's start the exercise and Q&A. So feel free to ask any questions. So, and then if you have already finished all the challenges, then you can have your free time. You can do whatever here, or you can also leave. Yeah. Right. Then I will stop right